This is Professor Birol KILKIŞ, a mechanical engineer, a graduate of the von Karman Institute in 1972 on fluid dynamics and aerodynamics, and a PhD graduate from the Middle East Technical University. I have spent about 17 years at the American Institute for Heating, Ventilating and Air Conditioning Engineers, and currently I am at the Austin Technical University Aerospace Engineering and Mechanical Engineering Department. EHP Technology is an innovative product which improves the performance of heat pipes, which are known as pumpless transfer medium for transferring heat from hot to cold points or cooling in the opposite direction. It is a three-phase medium which includes nanoparticle boron particles which enhance the heat transfer characteristics up to 15,000 watts per meter Kelvin. At the beginning, we were not quite sure how we can use and utilize this technology in the industry. But we have come to the point that according to the Enover's new heat pipe radiator systems, we have seen that with minimum or no oversizing need of the radiators, we can accomplish and satisfy the heating loads at supply temperatures as low as 35 degrees Celsius. This is a complete marriage with the European Union's low temperature, ultra low temperature heating systems at 35 degrees Celsius, which means we can use directly solar energy, solar heat, waste heat and any other heat and shallow geothermal heat without any need for temperature peaking with heat pumps, because heat pumps are responsible for carbon dioxide emissions in the sense that they destroy the electrical exergy by converting electricity to heat. Although they have a higher COP or performance coefficient greater than 1, their COP must be greater than 8 or 10 to break even, which is not possible today. So therefore we need some heating equipment, terminal units, and also cooling units in sensible cooling sense, such that we don't need any intermediate temperature peaking system like heat pumps, boilers using fossil fuels. So that's the main reason why we are focusing on heat pipe radiators in heating and both cooling. That means carbon dioxide emission reductions to a large extent, and at the same time we cut fossil fuel use and utilize waste heat, which is abundantly available all over the world, but at very low temperatures, which were deemed as useless before. So we are putting the useless, in quote, useless energy sources, waste heat sources to practice, and therefore we save energy. As I have already mentioned, the fifth generation heating systems or district energy systems, as mentioned by the European Union and all other countries including the United States of America, it means heating as low as 35 degrees Celsius supply temperatures, which are available everywhere in shallow geothermal energy sources, waste heat, solar energy heat, and by using this heat directly in useful form for heating with the same capacity is the major asset for the fifth generation district energy systems as coined by the European Union strategists. In the same token, because we save energy and utilize widely available waste heat and solar energy resources, geothermal energy resources, industrial waste, waste from power plants at temperatures like 40 degrees Celsius, which were not being able to use before, means directly carbon dioxide cutting, because we are not going to need fossil fuels. So we are directly and automatically eliminating the use of fossil fuels as mentioned by the Intergovernmental Climate Change Panel in 2022. This is the main target, to reduce or minimize as much as possible the use of fossil fuels. So this is a perfect fit for the future Paris Agreement goals of 2050. There are several factors in reducing the energy costs in buildings, heating systems and all other industrial applications because of their high efficiency and reducing the fossil fuel utilization need or even eliminating fossil fuels, and therefore by using almost costless waste heat, solar heat, byproduct heats of power plants, so they are actually the cheapest solution. Of course, provided that the market penetration progresses as expected, as we plan, because this technology is not only applicable to heating and cooling of buildings, other installations, but also industrial systems like the organic Rankine cycle type of power generation systems from geothermal energy with low efficiency. Their efficiencies are currently in the range of 10%. But by adding the same EHP material into the working fluid, its efficiency may increase by up to 10 points more, which means reduction in energy demand. With the intelligent heating and cooling systems, the response time of the systems are also very important because they don't have any pumping requirement. They have little water content using heat pipes. They are very responsive as 5 times than normal radiators, and therefore the response time is important, and also their performance number, which is an exponent in heat transfer equations, is almost 1 compared to 1.35 with conventional radiator systems, which makes them very responsive and also very competitive against the radiator systems, and making them competing systems with fan coils and usefully competent with all other heating systems in terms of intelligent systems that can be integrated to the new Enova radiators both in heating and cooling. Because they are much smaller compared to oversized radiators to accommodate low temperatures, they have little water content, they don't require pumping systems, so they are not oversized, they are not heavy, bulky, and at the same time, because of little water content, there is no corrosion, no pumping requirements, so pumping problems are eliminated. They are noiseless, and also they are seamless, and therefore they need almost no annual maintenance like all other radiators need because of leakages and other problems that we face every day. The EHP technology or Enova radiators with solar photovoltaic and thermal is a very special case. This is a very explanatory case, so I would like to explain that. A PVT technology on your roof generates both electrical power using PV technology, and at the same time uses the PVT technology to generate heat. But if you would like to connect this heat to a normal radiator operating at, let's say, 60 degrees or 55 degrees Celsius, you need to peak it up, a heat pump, a boiler, which renders it useless. And if you need to make the temperature output from the PVT at 65, which is possible, this means you are leaving the PV in a heated mode, so its efficiency drops. So the optimum temperature that a PVT system may provide is exactly 35 degrees, which fits directly to your new EHP technology, which means that solar energy is also going to get much benefit through PVT technologies, which means solar photovoltaic and thermal, by directly coupling PVT technology with EHP technology without any other supplementary equipment or fossil fuels. This makes solar prosumer buildings in district energy also a very advantageous alternative for tomorrow's heating systems in district heating. As I said, almost 60% or even 70% of the waste heat in the universe is at low temperatures, 40 degrees, 35 degrees, 55 degrees at most, which has limited usefulness to regular heating systems. But using the EHP technology in the NOL radiators, as I already mentioned, the 35 degree is a perfect fit for all these low temperature, which we call it low exergy, low enthalpy heat sources, which were deemed as useless before, will tap in to this vast, widely available heat source without any fossil fuel expense. Again, like in the dyeing industry, painting, textile industry, there are lots of waste heat. Also at the stacks of power plants. This heat can be extracted by heat exchangers, but heat exchangers need pumps. And at the same time, you need additional fans to maintain the natural convection of the heat transfer from the boiler or whatever you have from the source to release it to the atmosphere. But using heat pipes, you reduce the drag in the heat exchanger systems. You don't use pumps or fans. Therefore, industrial systems enjoy the advantages of EHP technology as much as heating systems. An example I have already given, the organic Rankine cycle system. The EHP technology increases directly its efficiency, which is already quite low. So a 10%, 15% point increase means much to the industry. For geothermal energy and other waste heat use, if you need to use low temperature heat to generate some electric power. To summarize, the EHP technology can virtually be applied to anything that you can conceive. As you may say that it's extreme application, but let's say snow melting in highways. Usually snow melting is done by either electric power, electric resistance heating systems, or hot water or warm water circulation by pumps using geothermal energy, but all are energy intensive. But if you use heat pipes without pumps, where you tap in the ground heat as low as 10 degrees Celsius, which is sufficient for snow melting or ice protection, it is again with almost zero energy demand. And also in the summertime, the asphalt coming hot may transfer the heat to the ground so that you store energy in the ground for the next winter season. So it's a very automatic, without energy and maintenance use, you automatically heat and cool or melt the snow of highways or critical areas, including airports and highways, and as I said, in the runways of airports at critical locations. So this is an extreme, seemingly an extreme example, but this is going to show you that you can use the same technology in any conceivable application where you have some heat transfer from heating or cooling or energy savings and waste heat recovery. It can be used anywhere. Absolutely yes. It is going to have, and actually already have, all the international certifications, and they are categorized under regular minimum ozone depleting and minimum global warming potential certifications, almost zero emissions. So therefore it is safe, also safe for humans. The boron is also an inert material, it's also safe. The technology has MSDS certification, which is the safety certification recognized by all international institutions.